So what if I told you there's a hidden pattern, like a secret signature inside every single number? That's the big idea behind this really fascinating document called the Puturan Digit Manuscript. It's a concept that's, both incredibly simple and surprisingly deep. And yeah, we're going to dive right into it.
And this is the question that really kicks the whole thing off. Is there some kind of secret code hidden in every number? Could there really be this hidden layer of meaning that, predicts patterns in everything? From language to the stock market? That's the mystery we're unpacking today.
Okay, so the key to this whole secret code thing is something called the digital root. And trust me, it's super easy to find. You just take any number, let's say 583, and add up its digits. In this case, 5 plus 8 plus 3 equals 16. Now, since that's not a single digit, you just do it again. 1 plus 6 equals 7. And boom, that's it. The digital root for 583 is 7. Simple, right? But this little process, this is our key to figuring out what the manuscript is really talking about.
All right, to really get what's going on here, we got to look at the math behind it. And the manuscript has a great way of thinking about it. They call it the 9-hour clock.
So the fancy formal name for this is modulo 9 arithmetic. But seriously, don't let that name scaring off. All it means is that we're playing in a little sandbox where numbers just wrap around after they hit 9. So 10 becomes 1, 11 becomes 2, and you get the idea. The big takeaway here is that finding a digital root, it's just a slick shortcut for finding a number's value in this specific mathematical world.
The easiest way to picture this is to literally think of a clock that only has 9 hours. Once you pass 9, you don't go to 10. Nope, you circle right back to 1. Every single number you can possibly imagine has a spot on this 9-hour clock. And that spot, that is its digital root. Okay, now this is where it gets really cool. Inside this 9-hour clock, not all numbers are created equal. There's this special little set, 1, 2, 4, 5, 7, and 8, that forms this unique club. Here's the deal. If you multiply any of them together, the digital root of the answer is always another number from that same group. It's like they're in a perfect closed loop. Let me actually show you what I mean. Okay, let's just see this thing in action. We'll start with the number 2. Multiply it by 2, and of course, we get 4. Multiply by 2 again, and we get 8. Pretty straightforward so far, right? But now, watch this. 8 times 2 is 16. And what's the digital root of 16? It's 7! See? We've just wrapped around the clock. Let's keep going. 7 times 2 is 14, which has a digital root of 5. And for the grand finale, 5 times 2 is 10, which brings us right back to a digital root of 1. It's this perfect 6-step cycle that hits every single number in that special group. It's just a beautiful, self-contained mathematical pattern. So yeah, the patterns are elegant, for sure. But do they actually mean anything in the real world? Well, the manuscript put this to the test. They took 1 million random numbers, crunched the digital roots for all of them, and then plotted how often each one popped up. And this chart, this is what they found. The distribution is almost perfectly flat. I mean, every digital root from 1 to 9 shows up just as often as any other. It looks, well, completely random. Which, let's be honest, is not what you'd expect if you were looking for a secret code. So, if it's not some secret code to the universe, what is it actually good for? The manuscript went and tested these digital roots in the real world to see where they might, actually be useful. And here it is, the report card. On one side, you have the wins. Digital roots are a huge win for stuff like checksums. That's a simple way to check for errors when you're sending data, and for writing really fast computer algorithms. But then you look at the other side, the fails. When it came to finding any kind of hidden patterns in the stock market or in the length of words in different languages, yeah, they came up completely empty. And the manuscript is super clear about this point. I mean, they crunched decades of data from the Dow Jones Industrial Average, and I'm quoting here, they found a negligible effect size. That's basically the scientific way of saying the digital roots of the stock market's closing values had absolutely nothing to do with how the market performed. Zero. No predictive power whatsoever. But hey, let's not just brush past the wins, because this one is actually a big deal. Remember that 9-hour clock idea, the whole modulo 9 method? Well, the manuscript found that using that trick to calculate a digital root is up to 30% faster for a computer than the old way of just adding digits over and over. In the world of high-speed computing, that is a huge improvement. So after all this digging, all this investigation, what's the final verdict on this supposed secret code of digital roots?
It really just boils down to this. The myth was this grand idea of a secret code to the universe. But the evidence, it just doesn't back it up. It fails predictive tests in finance, in linguistics, and it just distributes randomly in big data sets. So the final verdict is this. A digital root is a really clever, really efficient mathematical tool. But it's not some mystical key. So the myth is officially busted. The Pateran digit manuscript really shows us that while the idea of a secret code is, super alluring, the reality is often about finding these elegant, practical tools. Digital roots don't predict the future, no, but they do reveal this beautiful, cyclical structure hiding inside our number system, which really just leaves us with one final thought. What other simple secrets are just hiding out there, in plain sight, waiting for us to figure them out?